Hello, everyone, and welcome to today's SpudSmart Roundtable Series webinar. My name is Ashley Robinson, and I'm the editor of SpudSmart. Today, I'll be serving as your host for this webinar. Today's theme is the latest practices for the use of liquid and dry fertilizers. I'd like to take a minute to thank BASF and McCain for partnering with us on this Roundtable Series webinar. Today's presenters are Alan Baylock, a senior agronomist with Nutrien, and Tommy Roach, Vice President of Product Development and Technical Services with Nature Alpine Solutions. In today's webinar, you'll learn about the effect weather has on fertilizer applications, what the optimal field conditions are for fertilizer applications, how new technology can help with fertilizer applications, which type of fertilizer works best for your personal operation conditions, and how new fertilizer formulations can help your crop. During the presentation, you'll likely have some questions for our speakers. Please type these into the chat box at any time during the webinar, and we'll address them during the question and answer session after the presentations. Today's webinar is being recorded and will be made available at SpudSmart.com following this live event. Our first presenter is Alan Baylock, who earned a PhD in soil fertility from Iowa State University and his Bachelor of Science and a Master of Science degrees in agronomy from Brigham Young University. He has been working with Nutrien and its predecessor Agrium since 1996, supporting in marketing, sales, and product development. He has managed Nutrien research and education programs in key global markets, such as North America, Europe, and China. He has worked with Nutrien's product development team and managed field research and marketing projects for ESN and related products since 2001. Prior to joining Agrium in 1996, Alan was an extension soil fertility specialist at the University of Wyoming. Alan has served on numerous regional and national committees and as an officer of multiple divisions in the American Society of Agronomy and Soil Science of America. He was recognized in 2018 by the Soil Science Society of America with the Soil Science Industry and Professional Leadership Award, and in 2010 by the American Society of Agronomy with the Agronomic Industry Award. Alan is a recognized expert in the fertilizer industry, especially in the enhanced efficiency fertilizer sector, and has spoken on nutrient management at numerous national and international conferences. Take it away, please, Alan.
Okay, today we're going to talk about some practices for fertilization of potatoes and how a potato grower might approach his fertilizer program with the various materials available and some of the pros and cons of different things. And we'll also get into a brief discussion about some of the new things that might be available. So what we're really trying to do is, as I like to put it, supply what the crop needs when it is needed in a form that's available to the plant or something that becomes available when it's needed. And our end goal is to meet social needs for food production, long-term sustainability, and particularly today, minimizing impacts on the environment. And we in the fertilizer industry like to talk about this as 4R nutrient stewardship, which simply means supplying the right source at the right rate, at the right time, and in the right place. So that sounds fairly simple, but can be very complex for the grower in that decision process. We'll go through a few things that are pertinent, particularly to potatoes. So with potatoes, we have a very complex situation. We have a crop that's very sensitive to nitrogen timing and amount. It's shallow rooted. We're usually applying high fertilizer rates. It's often grown on sandy soils that may be prone to nutrient loss. We're supplying water through irrigation, or we're growing them in humid regions. And it's a high value, intensively managed crop. So we want to make sure we get it right. So that creates this complex system with lots of nuances going on in the background. And I want to point out a couple of things particularly. I'm going to talk a little more about nitrogen, but particularly with nitrogen, it's a challenge because we want to regulate the amount of nitrogen that's available to the crop through the season at particular times. Too much or too little causes yield loss or loss of quality, and can also lead to losses and inefficiencies. So it's a really complex system, and so we manage it throughout the season, unlike some of the other crops that we might grow, like corn or cereals, some of those things. So in slide 4, the next slide, we're showing some data on weather events and weather cycles. We have been hearing a lot from climatologists that we're entering a period of more extreme weather events, more volatile weather events, and that creates even greater challenges. And you can see here in the recent years on this graph that we're in the upswing in a cycle of more volatile weather. This graph is simply showing the percentage of the U.S. that's receiving greater than normal portion of its rainfall in single day events. So that means we're going to have large nutrient loss events. It's going to create challenges in crop management and really cause us additional complexities in our potato management system. The next slide illustrates potato growth and nitrogen uptake. Now, this graph particularly is for Russet Burbank. It's based on some measurements out of Minnesota in the US. And while the varieties are, we know, very different, the pattern that's represented here is fairly typical for really all varieties. The calendar may be compressed. Some may have more early nitrogen uptake. Some may have shorter season. They're more dependent on immediate nitrogen supply at the beginning of the season. So there are some adjustments that might be made for individual varieties, but the key thing we want to point out here is that for some period early in the season, there's very little nitrogen uptake. Now, the patterns are also similar for phosphorus and potassium, some of the other nutrients. There are nuances there, but early in the season, the plant is feeding off of the seed piece. And then as it reaches a point where tuber initiation starts to take place, we enter a period of rapid vegetative growth, and that's when the bulk of the nitrogen is taken up. It's taken up into the vines, and only later is it moved into the tubers. This is a critical period. During this period, we want to avoid too much vegetative growth because that can make us more prone to diseases, and at the expense of tubers, and prolong that tuber initiation period, in essence shortening the bulking period. So we need to manage the amount of nitrogen the potato is receiving. In some varieties, peak nitrogen uptake during this rapid growth stage can be as much as 7 or 8 pounds of nitrogen per acre per day. So they're really taking up a lot of nitrogen, they're taking up a lot of water. So this is a key time. And then as we get into the tuber bulking period, the uptake into the vines starts to decrease. And now we're moving nutrients into the tubers instead. And so that uptake tends to level off at that point and even decline towards the end of the season as the crop starts to mature. So these are the basic growth stages that we might use in our management decisions. So moving on to the next slide and starting to talk about some of our decision-making process. I show this map of North America, and this is taken from a soil test inventory that's collected every 5 years. Has been done by the International Plant Nutrition Institute. And the numbers reflected in this map are simply showing the percentage of soils that test below the critical levels for phosphorus. Now, I'm highlighting in the red circles some of our key potato growing areas across North America, the northern tier states in the US and Canadian provinces where we're growing significant potato acreages. And you can see that a high percentage of our soils in these areas are below the critical level for phosphorus. And when we look at the critical level for potatoes, it would be even higher than what was used for this inventory. So we know that most of these areas where we're growing potatoes, because of potato demand, its shallow root system, and the inefficiencies in phosphorus uptake, we're going to need substantial amounts of phosphorus. So one of the keys to managing this is to start with a good soil test. We need to be soil testing to know what we have. The point of this is simply to point out that many of the soils on which we're growing potatoes are low in phosphorus. We need to pay attention to that soil test. In the next slide, we're showing the same kind of data for potassium. And we see also that our potato growing regions, many of them are also low in potassium as well as phosphorus. So these are two nutrients that we really need to be paying attention to in a base fertility program, and maintaining adequate levels in the soil to avoid these deficiencies, in addition to possibly in-season supply. So in the next slide, what I'm moving on to is the thought process that a grower might work through for his seasonal program. And I've simply posed some questions here that a grower might think through to decide what he's going to do. And there are obviously more questions in this for any particular situation, but first of all, I want to establish that base soil fertility that I mentioned, using soil tests to establish what additional fertilizer needs to be applied. We need to think about, will it be broadcasting my pre-plant fertilizer application, or will I be able to bandwidth the planter? What sources and equipment are available? Am I using dry fertilizer, or am I using liquid with that equipment? Liquids may be suitable for certain applications, but some people may not have the equipment. Others may not have equipment to apply dry fertilizer with the planter. So these are all part of the decision-making process. Another question related to some of the recent research that's been done is this a good time for control release urea? In some systems, that is working very well to help manage nitrogen. We'll come back to that a bit later as under the new technology section. So next we want to think about, do I need starters? And many potato growers are applying starters with the planter. Typically phosphate, micronutrients. This is a good time to add those biostimulants that many growers are using. Again, comes back to equipment. What can I apply with the planter? There may be liquid or tank mix limitations. When I'm using liquid fertilizers, I need to be concerned about that. Dry fertilizers, we have fewer compatibility issues, but with the liquids, we certainly need to know what can go together and what can't. Then the big question about nitrogen that we need to think about. How will I regulate that nitrogen supply? Do I have nitrogen loss potential? Am I irrigating? Do I have the ability to put nitrogen through the irrigation system, what we call fertigation? Can I make mechanical in-season applications? Can I get through the field at an appropriate time and apply that fertilizer? And again, the question of control release comes up. How will I regulate that nitrogen supply to the crop so that I don't have excess, but yet I have adequate to drive the yield and quality that I want? And then lastly, thinking about the in-season part of my system. Will I need to make P&K applications in season? Is that feasible for me? Again, there's fertigation on, but if I'm not irrigating, how do I get P&K on in season if I need to? Do I need additional calcium? Many of the soils in which we're growing potatoes are sandy soils. They're low in calcium, often acid soils, and calcium can be beneficial. And we have soluble calcium sources like calcium nitrate that may be beneficial during that time. Can I get that on? And how will I do that? What micronutrients may be needed? And oftentimes we may be needing to apply those in season. Foliar application is popular for this, but will that be possible in my system with my equipment? So anyway, these are some of the thought process that a grower might go through as he sits down to plan out the potato nutrient management program and think about the sources that are available. We talk a lot about liquid versus dry, and many of those agronomically they perform very similar, but they may have advantages or disadvantages for a grower's system, given his particular needs. So let's go on to the next piece. I want to talk a little bit about nitrogen loss and how that fits with potato management systems. We mentioned the sandy soils, the shallow root system, the water that we're applying or receiving through rainfall. And as I see it, there are two basic nitrogen loss risks. One is urea left on the soil surface, and the other is nitrate in the soil that can be lost by denitrification or leaching. Urea on the surface is a volatilization risk. That's a short-term risk. Losses occur within a few days after the application. Losses from nitrate can occur at any point in the season when we have nitrate in the soil accompanied with rainfall or irrigation events. The risk of urea volatilization from surface applications, in my opinion, is very low in potato systems because we're usually incorporating that nitrogen. We're in high rainfall areas or we're irrigating and we can move the nitrogen into the soil. So that, in my opinion, is a low risk in potato systems. But the loss by leaching is very high. And so or the risk of loss is very high. So that's something we want to manage for. So in the next slide, I'm simply looking at, okay, how do we reduce that loss? We can manage our 4 Rs, source, timing, rate, and placement to reduce that risk, make sure we're incorporating the nitrogen or we're making split applications, put it out there closer to the time of crop need, and spoon feeding the crop as it were where possible. The other alternative is we can alter the fertilizer in some way to manage the nitrogen form and timing. As an example, we can use control release nitrogen to supply the nitrogen as needed. We can use nitrification inhibitors to slow the conversion to nitrate and reduce the risk of leaching losses. So there are things that we can do to manage that either with our conventional management practices, our 4R practices, or new technologies to help control those losses. So I want to talk just a few minutes about enhanced efficiency fertilizers, and then we'll wrap up. So these are fertilizers that are a category of fertilizers that are altered in some way to change the mode of action, as it were, in some ways, that they're either adding a stabilizer to the nitrogen to change the rate of transformation or controlling the rate of supply. And there are many proven technologies and lots of new products coming on the market that perhaps don't have the background research as much. So we need to look into those. But in any event, it is essential that we match the mode of action of each product to the specific objective we're trying to achieve. So it's important to understand each product and understand the challenges we have in the field and how those match up. So in the next slide, I show some data from University of Minnesota, Dr. Carl Rosen and his colleagues looking at some of the stabilizers that are available and combinations with urea. And in this particular study, we didn't see a lot of yield response or nitrogen uptake response. Those were not significantly affected, or even leaching loss, but there was a significant reduction in nitrous oxide emissions. Now, if you're looking simply numerically, there are some small improvements in yield and tuber size and nitrogen uptake with the inhibitors, but not statistically significant. So something that maybe should be examined a bit further, but certainly one environmental impact was reduced. In the next slide is a study from Dr. Mario Tenuta at University of Alberta where he was comparing a control release nitrogen source called ESN with some other practices, other sources and conventional practices. Draw your attention to the bars on the right. where the treatments were pre-plant urea followed by fertigation either 3 or 4 times, kind of the standard program that an irrigated potato producer might use. And then the dark green bar with an ESN application, all applied pre-plant. So in other words, substituting a fertilizer technology for those multiple applications, and they're very similar in terms of the performance. So perhaps an option for some who would like to reduce their in-season labor requirement. In the next slide is another example of a study using ESN, and I highlight this one particularly because it's interesting in that it illustrates how a technology can be combined with some of our conventional 4R practices. So in this slide on the left, we have the grower's practice. That's a pre-plant application or urea application at hilling, followed by 9 fertigations through the season. So more or less continuous nitrogen supply through the season in the standard practice. Then the next 3 bars are the control release nitrogen source, all applied at emergence. So 1 nitrogen source, 1 application at 3 different rates. And you see those are fairly similar. And then on the far right is a combination of ESN at emergence, followed by different amounts of fertigation. So basically what this is showing is that there are a number of options, a number of ways to use a product like ESN in conjunction with some of the conventional fertigation. So retaining the flexibility of some of those standard practices while reducing the in-season workload and still achieving some excellent results. So just to wrap up on the, summarize on the inhibitors or what we call stabilizers, the urease inhibitors, I think, again, in my opinion, are generally not as beneficial in potato production. The nitrification inhibitors do have some benefits in terms of leaching and denitrification potential, but keep in mind that on sandy, low cation exchange soils, it may be more difficult to protect against leaching simply because infiltration rates are so high. We don't have the ability to retain the ammonium, and multiple applications may still be needed anyway. Keep in mind that neither of these technologies, even though they're effective at what they're designed to do, they do not regulate the nitrogen timing, so we still need to do something about controlling the nitrogen supply. So the next slide is simply a table that I've put together, kind of a summary of my overall view from the research that's been done on how effective these are and the amount of benefit in potato production. More plus signs means greater, fewer plus signs means a lesser benefit. So you can take a look at that and kind of see one thing that we have seen in lots of research in the last 15 or 20 years is control release fertilizers have really performed well. Among the enhanced efficiency fertilizers, they've been the kind of the best choice for potato production. And lastly, to wrap up, I'd like to make a few comments about biostimulants, or what sometimes are called biologicals or microbials. This is a rapidly emerging sector in the market. Now, many of these products have been around for quite a long time, but have not received the attention that we have in recent years. There's lots and lots of investment money flowing into this sector and many new products being developed. But there are still many scientific questions that remain. And there's a wide range of products. Some of these include organisms, some do not. Some are organic compounds derived from biological processes. Many times the modes of action are not well understood. And so we need to look into those and make sure we understand what it is we're buying and how to use it. Sometimes it's hard to find third-party validation of that data. The results are largely from the companies selling the product. So it can be sometimes difficult to evaluate what's really going to fit for me in my system. But spend your time, do your homework, understand the system and the product. But we do know that these products are rapidly gaining acceptance. There's great interest in the government agencies, and as the science develops, and it is developing rapidly, there's likely to be greater and broader acceptance. So with that, we'll conclude, and I've provided here some websites and email addresses where you can visit us, Nutrien, for more information. Our Nutrien Economics website has lots and lots of agronomic content, from articles to videos to a variety of calculators and resources that you can use. And so with that, I'll conclude, and we'll take whatever questions there may be at the end of the webinar.
Thanks, Alan. Remember, if you have any questions for the presenters, please type these into the chat box at any time during the webinar, and we'll address them during the question and answer session after the presentations. Our next presenter is Tommy Roach, who is currently Vice President of Product Development and Technical Services for Nature's Alpine Solutions, headquartered in Marion, Ohio. As part of his North American duties, he is tasked with finding new ingredients and/or combinations of existing ones to continue the upward trend of crop yields, but at the same time balancing this with environmental stewardship and sustainability. Tommy graduated from Texas Tech University with a Bachelor of Science degree in Animal Science and a Master of Science degree in Crop Physiology. He has worked in the agricultural industry since then for Delta Pine, DeKalb Genetics, Monsanto, and Core Agri in various roles, which included sorghum breeding, research agronomy, and fertilizer formulation. Tommy currently lives in Lubbock, Texas, with his wife and their 5 children. Take it away, please, Tommy.
So today we're going to talk about challenging the status quo in liquid potato fertility, especially in terms of phosphorus and potassium usage. So we can apply fertilizer as dry or liquid, and a lot of the same application methods go back and forth. So if you look at specific to liquid fertilizer application, we have 3 that are specific to liquid. We have in-furrow, we have fullyear, and we have fertigation. So there's more opportunity to affect plant growth and development during the growing season, as well as to boost nutrient use efficiency with the use of liquid fertility. So as we know, nitrogen is directly related to yield and gets all the attention. However, if another nutrient such as phosphorus or potassium is the limiting nutrient, production will decrease and genetic potential will not be fully realized. It's like having a full tank of gas in your truck, but having a flat tire. In either case, you will not get very far. So this kind of relates to the Liebig's law of minimums. The total solids or quality in potato production is a function of the amount of pectin and the density of the finished product. This is achieved with a well-balanced fertility program that pays attention to not just 1 or 2 nutrients like nitrogen alone or phosphorus alone, but to all nutrients involved. So here on this slide, we have a couple of studies, one from Mongolia, one from Germany, showing what the balanced fertility does to overall potato production. So if we look at the right place, time, source, and rate of nutrients, which is known in the 4 R's, in terms of phosphorus, we're going to focus on source and placement because that is very important in phosphorus management. So with phosphorus fertility, we can, of course, broadcast phosphorus. We can broadcast and then till it in. In terms of applying phosphorus with the planter, we can single side band, we can dual band, we can put phosphorus beneath the furrow, as well as band it out to the side, because of, if you think of how potatoes' root architecture is, it doesn't grow down like, say, a corn plant. It actually goes out and up. And there's another application method that we'll talk about later. Even though potato has a relatively low seasonal uptake requirement for phosphorus, it does, however, have a high requirement for soil available phosphorus, indicating a low uptake efficiency. So if we look at what is happening with phosphorus application across the northern states in the U.S. as well as Canada, where we grow potatoes, overall phosphorus application is increasing. But if you just look at what's happening, say in the western U.S., where potato production is increasing, we see a 32% increase in soil test P in the western U.S. as well as in Manitoba. So if you look at why is all this extra phosphorus being applied? Well, if you compare the rooting structure of, say, potato versus wheat, you have about 1/4 of the root density as compared to wheat. And if you consider phosphorus, once you apply phosphorus, it doesn't move hardly any. So that's why we want to talk about in-furrow placement of nutrients. So if we talk about orthophosphate fertilizer sprayed over the seed piece at planting, that's what we call in-furrow fertilization. Why do we talk about orthophosphate? So there's two types of phosphate fertilizer, ortho and poly. Orthophosphate is the only plant available form that is taken up by the plant. If you look at polyphosphate, its conversion to orthophosphate may take days, weeks. It all depends on environment, temperature, moisture, pH, biological activity. And if we think of when we plant potatoes, the soil and air temperature is usually still pretty chilly, maybe dry. So those are all going to affect the conversion from polyphosphate to orthophosphate. So if we think of in-furrow, we think of banding, that's going to create a handoff or a relay effect. We know there are varietal responses to the type of phosphate fertilizer. In this study here, one variety had a huge increase, huge response to orthophosphate compared to combinations of orthopoly or just polyphosphate by itself. The other two varieties that you see on the right, there really wasn't much difference between orthophosphate and, say, 80-20 orthophosphate to polyphosphate fertilizer. But those two did have a huge response to those type versus a 50-50 or a all polyphosphate type material. So when we talk about placement, we talk about banding. This study here is talking about banding off to the side, like you would typically think of banding phosphorus at planting. This study shows that there's a huge increase in banded phosphorus versus no banded phosphorus on top of a standard broadcast phosphorus application. Now, when I talk about banding, I'm going to talk about in-furrow banding as well as traditional banding off to the side. So in this next study, this is a study out of India that shows comparisons of in-furrow versus banding versus broadcast. And you can see by the line at the very top, in this study, there was a huge response to in-furrow fertilization. So in some of our work, this in the western U.S., this study was done over the last 2 years in Oregon, Minnesota, and Manitoba. And what we did was we took the standard 20-gallon 1034 banded program, and all we did was take some of that polyphosphate out of the band and exchange it for in-furrow orthophosphate. And as you can see, we increased yield by around 25 bags, as well as we improved our size profile. And we improved our phosphorus use efficiency as well. So if you think of the growth cycle of a potato plant, you have a distinct switch from vegetative growth to reproductive growth, and it's in that time of the switching that we tend to get a decline in petiole nutrient levels. So this is where foliar fertility comes into place. This study done in Idaho back in the 80s shows that you can have a tremendous impact on petiole nutrient status as well as yield by foliar applying phosphorus. Two different application rates of foliar applied phosphorus over on the left. And when we take that to yield, there was a substantial increase in bags for the 40 pounds of foliar applied phosphorus versus the 20 pounds of foliar applied phosphorus or no foliar phosphorus at all. Some work we did in Washington State this last year with a large grower trial out there. What we did was we made one application at 2 gallons of a foliar phosphorus fertilizer, just a single application, and you can see by this graph here, we increased yield 55 bags with a slight increase in gravity, and we were able to maintain that petiole P pretty much throughout the season. All right, so that's kind of the phosphorus talk. So let's move into potassium right fast. And again, there's a huge effect not only on source, but in terms of potassium, we want to look at the what's the right time to apply potassium fertilizer to a potato plant. So we know that potatoes, as well as other crops, have a huge need for potassium. So specific to a potato plant, potassium is known to influence discoloration during storage, discoloration during frying, hollow heart, tuber number, bruising, and even specific gravity. Believe it or not, potatoes actually take up more potassium than they do nitrogen. Same thing with corn. Upwards of 14 pounds of potassium a day during peak uptake. And there's no way that, given the constraints of a potato root system, that plant's going to be able to supply this much potassium during this short window of high demand. So the application rates of nitrogen and phosphorus fertilizers have increased annually, whereas application rate of fertilizer potassium is still flat or even declining. And down at the bottom that you see in green there, farmers generally believe that potassium fertilizer does not effectively increase crop yields compared to nitrogen and or phosphorus fertilizers. So just if you think of where the potash supplies are in the world, there's a huge one right in Western Canada, which is the largest one in the world. Canada is the #1 producer of potash in the world, followed by some Russia, China, Belarus. But don't think that there's ample potassium in Western Canada that you don't have to apply any further potassium. Here is a soil test, 2 soil tests from Western Canada. And as you can see, it's, average or below average in potassium content. So what you may not realize is that number that was on that soil test report, only 1 to 3% of that number is actually available to the plant during the growing season, and this is due to various and sundry physiochemical factors that are in the soil. So all this goes to this point. And here's a map showing potassium application versus removal in the U.S. And what you'll notice, the areas that are in orange and red, upwards of 6 to 12 times the amount of potassium is being removed than is being added. So if you look up at Montana, North Dakota, you see all that red, don't think that stops right there at the border. That same trend is happening north of the border in Alberta, Montana, Saskatchewan. So why is this happening? The 7 deadliest words in agriculture. Because we've always done it that way. Everybody has always applied just dry potash, which isn't the best thing to do historically. So you're probably wondering, what does beef have to do with potato production? Well, I just want to prove a point. So beef is a large term. You have different cuts of meat from a beef animal. If you look down at the bottom, you can have briskets, you can have short ribs, chuck roasts. On the right, you can have ribeyes, strips, T-bones, porterhouses, tenderloins. I don't know about you, but I would rather have the cuts of meat on the right versus the left. It just goes to prove that even though it's beef, there's a huge difference in taste, flavor, texture, and all these different cuts of meat. So everybody understands that there's different forms of nitrogen: urea, ammonia, nitrate, slow release, amino. And also there's different forms of phosphate. There's orthophosphate, polyphosphate, and rock phosphate. Same thing can be said with potash. People think of potash, they think of dry KCl or MOP. Here's some different forms of potassium fertilizers that can be used. Some liquid, some dry. But there's a lot of different forms that are out there that can be used. So with, say, fruits, vegetables that we eat, there's a huge amount of variance in potassium content of these different foods within a food group. Well, the same can be said with potassium fertilizers. There's liquid, there's dry, they have different molecular weights, they have different analyses, they have different solubilities. All this goes to prove that we need to choose the best one that fits in our farming operation. And we'll kind of sort through some of these here in a minute. A study done back in the mid-80s, kind of dissecting all these different potassium fertilizers. The bar on the left, which is potassium acetate. This study was done foliar applied on soybeans, and for the amount of potassium acetate that was in the plant after 48 hours was 47%. All of the other potassium sources that you see over on the right, less than 10% of the potassium was into the plant after 48 hours. And if potassium can't get into the plant, it can't do what it's intended to do, which is maintain ionic balance, cell integrity, stress tolerance, disease resistance, and so on and so forth. So for the past 47 years, Alpine has been an industry leader in Canada for high quality specialty NPK orthophosphate fertilizers for use both in furrow and foliar. So over the last 2 to 3 years, Alpine has broadened their product offering to improve crop quality and yield. We've introduced a new line of potassium acetate-based fertilizers branded as K-Tech. A lot of the research that we've been doing in the U.S. with this line of products has shown great potential in potato production, especially in achieving improved tuber quality, higher yield, and increased nutrient use efficiency. So some research work done back in the early 70s shows the effect that potassium brings to decreasing hollow heart. That you can see the top row was just a nitrogen and phosphorus fertilizer and its associated hollow heart. The next row shows what happens when we add potassium to that nutrient offering, and it goes to decrease hollow heart. For the last 2 years, again, we've done some work in Manitoba, and in the orange bar that you see there on the left, again, that's just your standard 20-gallon 1030 furrow banded, and all we did to that was we added 2 gallons of Alpine K24, which is our potassium acetate fertilizer, as well as a microbial offering. So we added all that in the blue there, and we see about a 20 bag increase in yield, as well as better specific gravity, and you'll notice a pretty substantial decrease in hollow heart. So I know there's not a whole lot of chips grown, especially in Western Canada, but this is some pictures out of Wisconsin back in 2017. And this is foliar application, whereas the previous one was soil applied application. Picture on the left, that's just a grower standard where our research work is done in Wisconsin. And all we did was take and use our foliar potassium program to the picture on the right. And you can see a better frying potato as well as basically non-existent hollow heart in this study. So we talk about foliar potassium. Here's some work we did this past summer in Washington State with a large grower trial. And if you look down at the bottom right-hand corner, you see a soil test K of, we'll just call it 500 ppm. So based on recommendations, one would tell you that there's no need to apply any additional potassium on this field. But yet, if you look at the yield box, which is on the left, just by applying 2 gallons and a quart of a foliar potassium, we had a drastic improvement in yield. And then on the specific gravity box on the right, substantial increase or an improvement in specific gravity. Again, some work we did this past year and we'll continue to do at Oregon State. Again, taking that 20 gallons of banded 1030-40, and you can see its associated yield, gravity, tuber K, how it fried, and then all we did was come over the top of that with our foliar potassium program. We saw an improvement in over 60 bags on yield, an improvement on specific gravity, a huge improvement on tuber K, which has a direct correlation to how that potato is going to fry. And talking about how it fries, here's 2 pictures from the trial this year. The one on the left was the grower standard. The one on the right was the addition of our foliar K, and typically potatoes out west don't have a huge problem frying white, but the addition of our Foliar K program, you see very little sugar ends in this picture here. Again, some work out of Manitoba with this same concept of covering over the top with a foliar potassium treatment. And in this study, we have about a 35 bag increase in yield, better size profile, and better gravity. And then lastly, if it can work in the West, well, what does it do in the East? Here's 3 grower trials that we did on PEI last year. Not the same separation from standard and potassium treatment, but still a nice gain in marketable yield. So in terms of liquid phosphorus and potassium fertility, use of the right source at the right time with proper placement can and will increase tuber yield, improve tuber quality, and lead to greater nutrient use sufficiency. And I would be glad to take any of your questions at this time or at the end of the webinar. Thank you.
Thanks, Tommy. I'd now like to do a short question and answer session. If you have a question for either of our presenters that you haven't typed in yet, please type it into the chat box now. Okay, so we have a couple of questions here. Let's get started and make sure to type any other ones you have. So first off, I think I'll just generally ask this to both presenters. Is there a promising novel tech idea for online monitoring of P and K levels on field conditions like drone technology? And if so, they're interested in knowing what the name of the equipment, camera model, software, etc. would be. So they just kind of want to know if there's anything out there. Tommy, would you like to start? And then Alan, you can follow up with anything you may have.
All right. Well, I would say the best way to monitor nutrient levels, especially during the season, is fortunately or unfortunately the old standard petioles sampling analysis. Of course, soil test prior to planting is always a good method, but you definitely need to use both to kind of formulate your fertility program, both prior to planting and during the season.
Okay, and Alan, is there anything else that you would like to add to that?
Yes, I'm not familiar with any remote sensing techniques for P and K levels. The challenge with that is you need to have a visual symptom in order to monitor that from say a drone or something, a camera. And oftentimes with P and K, we don't necessarily have a visual color difference on the leaf so much as we do with nitrogen. So you have to have something that's going to be responsive to changes in the level of that nutrient. And then you have to be able to calibrate that against levels of the nutrient. I'm not familiar with anything that's being done with P and K in that regard. That work today is really all around nitrogen.
Thank you, Alan. Okay, so our next question is, what nutritional effect for P and K do you ascribe to the repeated foliar application of potassium phosphate used for blight control? Alan, let's start with you since we started with Tommy last time.
Yeah, so we know that phosphite is it's a known fungicide, so there is some fungicidal effect, but along with that potassium phosphite, potassium is in an available form and so could be absorbed and used by the plant. Phosphite is not considered to be an available form of P to the plant. So the nutritional benefits of that would be really related to the potassium that's supplied along with the phosphite.
Thank you, Alan. Tommy, do you have anything to add to that?
No, I agree with Alan's answer. Anytime you can maintain plant health, of course, whether it's through phosphite, phosphorus, potassium, the better off you're going to be in the end. So I would agree.
Thank you. Okay. I just want to remind everyone, if you have any questions, make sure to type them in the chat box. Our next question is, how does foliar peat get into the plant? Tommy, why don't you start?
Well, again, like I mentioned earlier, phosphorus is taken up in orthophosphate form. If you use, it's not a good idea to even consider using polyphosphate through either foliar or through fertigation, because well, you can run into various problems, but plants only uptake orthophosphate. The old standard of 0.22% petio level, you can pretty well maintain that through the season, given the use of foliar. Phosphorus, you don't have soil interactions to deal with, especially in high calcium or aluminum situations. So foliar phosphorus is gaining more attention from what we've seen, and it's a good way to maintain plant energy throughout the season.
Thank you, Tommy. Alan, do you have anything to add to that?
Yeah, I would add to that foliar nutrients, and this question is specifically about phosphorus, but the answer would be pretty much the same for other nutrients. Those nutrients can be absorbed through the leaf, the cuticle of the leaf. They get into then the cells or the vascular system of the plant, and mobile nutrients could be transported from that, the point of contact. But the leaves are, provided we're not supplying excess and inducing a toxicity or a burn, those nutrients can be absorbed directly through the leaf cuticle into the leaves and be used by the plant. So for particularly at times when uptake from the soil may be impaired, or times of rapid uptake when soil uptake of nutrients can't keep up with plant demand, that foliar application can be a great way to supply those nutrients, because assuming we're using the right form that's available, not phytotoxic, and there are differences among forms, as Tommy mentioned, but the nutrients can be taken in very directly. And a great example where this is really maybe even better than soil use is micronutrients, because there's so many chemical reactions that reduce their availability, that foliar applications may sometimes be superior during those periods of peak demand, or if we have unfavorable soil conditions. So yes, it's direct absorption is the mechanism there.
Thank you, Alan. Well, that's all we have time for today. I'd like to thank our speakers, Alan and Tommy, for joining us. I would once again like to thank our sponsors, BASF and McCain, for making this webinar possible. And a big thank you goes out to everyone for participating today. I hope you have found this information of value. Again, a recording of this webinar will be made available on SpudSmart.com at a future time soon. And thanks again, and we hope you have a wonderful day.